This video is to help people who are struggling with the concept of moles, and in particular applying the equation mass equals Mr. Mole. It builds on the videos for basic chemical formula and for MR. If you don't know what those two terms mean, you need to go back and check those videos out before you move on to this one. Okay, so first of all, what actually is a mole? Well, something you're probably more familiar with is a dozen. 1 dozen is 12. It doesn't really matter what it is. A dozen eggs is 12 eggs. A dozen cars would be 12 cars. It's just a number. 1 dozen is shorthand for 12. Now in chemistry we don't deal with dozens. We deal with rather larger numbers, and a mole is simply a large number. 1 mole represents 6 times 10 to the 23 whatever it is. So if you were to go and get a mole of eggs, you would have 6 times 10 to the power of 23 eggs. That's rather a lot. To give you an idea of how big that number is, that's more than the number of stars in the known universe. So why do we need such a big number? Well, it's basically because atoms are very, very small, and to get a decent number of any that you could actually sort of work with, you're going to be dealing with numbers of this sort of size. Obviously it would become a bit of a pain having to constantly type 23 zeros into a calculator every time you wanted to do some maths, so instead of using the actual number of atoms, we work out how many moles of atoms or molecules or chemicals we're dealing with at any one time. So why have we chosen 6 times 10 to the 23? Why not something else? Well, this is the number of atoms that if you have that many atoms or molecules of a chemical, its mass in grams is the MR of the chemical. So the mass of 1 mole of a chemical is its MR in grams. So if you had 1 mole of lithium atoms, you would have 7 grams, because that is the MR of lithium. We can turn that into an equation, and here it is. Mass equals Mr. Mole. That's mass in grams is the relative molecular mass times the number of moles. Annoyingly, this is one of those equations you're not given in a GCSE science exam. You get all the physics ones, but you don't get the chemistry ones. Okay, so here is the equation. Let's see if we can do something with it. So, an example question. What is the mass of 7 moles of lithium? We're given the relative atomic mass of lithium, it's 7, although if we weren't given that, we could simply go to the periodic table and get it from there. So 7 moles, well, if 1 mole is 7, then 7 moles is 49. Using the equation, we have 7 moles and the mass is 7. Simple as that. It doesn't matter that we're actually dealing here with an AR. ARs and MRs are interchangeable in any of the equations we're going. Okay, so a harder one. What is the mass of 2 moles of C2H4? Again, we're given the relative mass of C2H4, it's 28. We just apply the equation. We know we're after mass, we know the relative mass, and we know the number of moles. Stick it all in the equation, and out it comes, 56 grams. It's really important that you put the unit on here. If you put 56, you will generally get it marked wrong. These are generally 1-mark questions, and if you don't have the unit correct, you'll lose that mark. Okay, so that's a harder one. They're now asking us a slightly different question. It's not how much does so many moles weigh, it's how many moles is 90 grams of this chemical. Now we've got the relative mass of C2H6, it's 30, but we need to rearrange the equation. Instead of mass is MR times moles, what we need is moles is mass divided by MR. All we've done is taken the MR, we've divided both sides by the MR, so it becomes over here, and we get this equation here. If we now put the numbers in, 90 divided by 30, it's 3 moles. And again, you need a unit here, okay, because we're talking about something specific here. It's not just 3, it is 3 moles.